Hello, I'm Amit Kirschenbaum from the Institute for Applied Informatics in Leipzig. I present Challenge 3, whose focus is analysis of drought conditions. What is drought? Drought is a natural hazard that can be loosely defined as an abnormally long time period of water deficit. The time period is abnormally long, but is still temporary. Europe has experienced several drought events for over a decade, which led to devastating impacts on livelihoods, ecosystems, and agriculture. Though droughts cannot be avoided, we can still try to manage them better and reduce their effects. This requires, first, monitoring drought conditions in a timely manner and evaluating their severity. There are different drought subcategories, and in Stargate, a project in the field of climate-smart agriculture, our interests are mainly in meteorological and agricultural droughts. Our study area is South Moravian region in the Czech Republic. The region is mostly agricultural, that is 60% of the region is agricultural land. And in addition, it is one of the driest areas in the Czech Republic, and thus drought monitoring may play a significant role in various levels. There is no single index for modeling drought, and in this challenge, we examined two. SPI, the Standardized Precipitation Index, is the most commonly used index worldwide for detecting and characterizing meteorological droughts, and is recommended by the World Meteorological Organization. It measures precipitation anomalies at a given location by comparing the observed amount of precipitation for a time span of interest, like 1 or 2 or 3 months, with a long-term precipitation record for that period. So SPI with time span, also called scale, of 3 months will be called SPI3. Similarly, SPEI, Standardized Precipitation Evapotranspiration Index, is also an established drought index. It uses monthly differences between precipitation and potential evapotranspiration. It measures anomalies of this difference by comparing the observed difference with the long-term difference record for that period. SPI and SPEI classify drought and wet conditions according to scales. So for example, value of -1 or lower is considered dry condition. For climate data, we use monthly precipitation via CMORPH and monthly reference evapotranspiration via NEMS4. Both resources provide high spatial resolution data. CMORPH resolution is 8 kilometers and NEMS4 resolution is 4 kilometers. We use data from the years 1991 to 2020, retrieved via MeteoBlue API. Missing values, mostly in the farther past of this era, were filled with global resources. For example, NEMS Global. Experimental results. As I said, these indices, SPI and SPEI, measure anomalies by comparing observed values with long-term record for the period. We examine how long should this long-term be. Here we see, for example, 2 configurations for SPI3. On the left, we can see history set for the years 1991 to 1995. And on the right, history set to the years 1991 to 2009. And as we can see, the drought events of the more than a decade are accurately observable when the history is longer. Next, we find correlation coefficients between indices, SPI and SPI, and VCI. VCI, Vegetation Condition Index, is an agricultural drought index based on satellite data. It measures anomalies of the greenness of an area based on red and near infrared bands from remote sensed images. So for example, on the left, we can see correlation of SPI3 with VCI. And on the right, the blue line represents the correlation of SPI3 with VCI. Moreover, we also compute correlation between VCI and SPI values from a global SPI database, which provides information on a global scale, but its resolution is not as fine as the resources that we use. This is the orange line on the SPI3 graph on the right. Then we found correlation coefficients between the SPI and SPI indices and VHI. VHI is a vegetation health index. It's also an agricultural drought index based on satellite data. It combines VCI and TCI, which estimates temperature by infrared band of remote sensors. VHI decreases, for example, when the greenness estimation decreases and the temperature estimation increases. This shows the stress level of crops and over a long period would indicate drought. So for example, on the left, we can see correlation of SPI3 with VHI. And on the right, the blue line again presents correlation of our local resources of SPI3 with VHI, and the orange line is a correlation of global database SPI3 with VHI. We observed in general that the highest correlation across different scales were of VHI with SPI, which was calculated from resources with high resolution. This shows the usefulness of both the resources and the SPI. Finally, we computed correlation between SPI and yearly yields in tons per hectare of selected crops from the South Moravian region based on years available in the free version of the Czech Statistical Yearbook. The sample here was rather short, of 2007 to 2019. We can see here, for example, SPI correlations with different scales of yearly yield of silage maize. Silage maize is typically harvested in September and October, and the information here hints that there is larger sensitivity to water stress during summer. As I said, the yield sample was rather short, and we didn't always have conclusive results. So for conclusions, we applied two drought indices, SPI and SPI, to data from South Moravian region. We used resources which provided climate data with high spatial resolution. This can be useful, for example, in areas with low coverage of weather stations. We found that longer calibration of history record brings more informative results for these indices. And SPI was found to be better for agricultural purposes. Availability of data is always important, and this was noticed both when climate data was missing as well as yield data was not available in the farther parts of the past of the era. In the future, we intend to examine more indices and to develop an interactive visualization system for displaying indices values for different timescales and different durations. Thank you very much for your attention, and hope to see you again in further hackathons.